Hi guys, Tim Man again. Okay, been doing some more testing with this circuit. I have made up a different part of the circuit on the high voltage side. I've made these two coils, if you can see that properly, but I've made two windings, started from the centre, wound in a anti-clockwise direction. Same with the coil on the front, started at the centre and wound in an anti-clockwise direction. Both coils are independent from each other, they are not joined in any way, and one side of each of the coils is open. This is the open side on the high voltage side and the open side on the secondary side. Now that is the secondary coil, which I'm going to call it, comes out and into a diode. We've got the positive lead of the cap going to the positive side of the diode, the negative lead going to the negative side of the cap on the negative side of the diode, and this side of the diode is open, not joined to anything. So that'll come into play a little bit later. That's set up the same way as you've seen in the last videos. Same cap, whole shebang. But back to this. I'll just fire it up for a minute. As we've seen before, everything has a very high voltage on it. And this includes a very delicate 555 timer. Every pin on that is also fully charged. So what I was trying to work out with the likes of the 3055 transistors, the emitter to base breakdown voltage is 7 volts, from collector to base is 100. Now I know to get the gas fired up in these we need about 450 volts plus. Now as you can see, that fires that up no problem at all on the base. So the only thing I can come up with as to why everything's not frying itself is in the way that I have the coil hooked up. As you'll see in the schematic on the forum, it's the negative side of the coil actually goes to the positive side of the run battery, and the positive side is going to ground through the collector emitter. So my theory is that when this primary coil is collapsing, it's turning the positive side into a 400 volt plus negative. Now if I am ground or earth, which is 0 volts negative, in the normal situation, this is now becoming 400 volts of negative charge below that, which is giving us a potential difference of 400 volts plus between myself as the ground and the negative charge that is going through the whole system. So that is the only explanation. If it was a positive charge going through the system, these components would have fried themselves a very long time ago with that sort of voltage going through. So that's my theory on that. This coil is collapsing, pulling these down 400 volts plus below negative ground. But anyway, back over to this situation here. Our cap now has 1.1 volts in it. It, in this situation, doesn't go up as high as it did yesterday. It doesn't go up enough to even light our little LED. There is no high voltage going through there. I get no tickle or nothing. That is, unless of course I touch the water or the two outputs on the bridge rectifier. switch off the light, or one of them. Now like I said, there is nothing in there. It's 1.2 volts in that cap, not even enough to light the LED. However, our globe still goes, and that water still has a good little tingle to it. Now I took it off just so you could see it's legit. There's no tricky globe or anything there. That was the globe. 13 watt, 240 volt, 50 hertz globe. Now keeping in mind that cap is charged up to that voltage off of the diode with an open side from a coil that is also open, being excited by another coil that's also open. Now I know you're going to say the high voltage is just coming through the positive lead straight through there into the water, and I am acting as the ground. So if I disconnect the positive, we will see that the light does not glow. So now you are thinking, yes, you are right. Okay, so I'll hook the positive back up, and indeed our light goes again. But there's the tricky bit. If I disconnect the negative, as you can see, the voltage in the cap is starting to drop and the light does not go. So the power is not coming through the positive and into the water and making the light go, otherwise it would be going right now. Both these leads have to be hooked up either side of that open diode for this light to work. Which is very interesting, and same again if I disconnect the positive, the voltage in the cap starts to go down through the resistance in the water. But yes, both of those have to be hooked up for the light to work, which is quite interesting because both of them hooked up, going through the cap, through the two probes into the water, is basically a short. Now here's the other thing. As you can see, our light is once again working. Not quite as good as it was yesterday because we are using a different system and in no way coupled up to the high voltage straight from the coil like we were yesterday. But this little cap here at the moment is 6.8 volts. If I hook the power up to the cap, of course the cap starts charging a lot higher than the voltage that's in that cap, which is at 1.4. Now if we put our light in, the light doesn't go because we've reduced the voltage in the water to the same as what's in that cap. If we disconnect one of the leads so the voltage in the water can build back up, as you can see, we're off and going again. So it's actually showing that it's not working from the high voltage on the coil in the way that these are two open coils not hooked together. It's also an open diode, and the light will not work unless both sides of those are hooked up. The open diode is charging up the cap, which is slowly climbing. Again. So that's our voltage in the cap. You can see our little LED is just starting to glow, which is a very good indication that's all that's in that cap. However, what's coming out of our water once again, up to 54, 55 volts there now. So very interesting. Now one would think one would get a tickle from something here if there's any sign of high voltage going through, enough to light that CFL. Even though the amps are low, you would still feel it. And the only way I can feel it, as you can see, it's not going, which shows us that it definitely needs over 70 volts to work. Disconnect our cap, allow the water voltage to build up. It goes. And if you stick your finger in the water, that certainly lets you know that your finger is in the water. However, the probes going into the water are quite safe to touch now. Alrighty, so that cap will actually keep building up to about 340 volts, 345. Does take a while, but that's only because it's very low current. However, as you've seen with the globe, the voltage is very high, and all coming from this independent setup with an open diode. So that's what I've got to show you, and that was my theory on the CFL lighting up on all these electronic components that should not handle a high voltage like that. Like I said, I'm guessing it's a negative voltage, and the potential difference between ground, which is myself, and that negative voltage is enough to light the CFL. Alrighty, we'll be mucking around with it a bit more, and then maybe onto something else, a different setup, a few other things I want to try now that I know that one wire and a diode, an open diode, can produce a charge. Alrighty, thanks for watching. Cheers from the Tin Man.